When I first installed the DRO on the Bridgeport, I wasn't quite sure how I was going to mount the scale reader brackets. So what I did is I just took some careful measurements of the mill and modeled up a bunch of stuff in Fusion 360. And that gave me an idea of what these pieces will need to be like. I actually went ahead and 3D printed those parts and installed them on the mill, and up until now it's how I've been using the DRO. Well, the first thing I did was rummage through my supply of scrap and came up with a few pieces that should work once I machine them to the right size. Most of these pieces are too big, so what I want to do here is I'll put a little blue dicum on them and mark the actual sizes so I can rough cut them out on the horizontal bandsaw. Once they were rough cut on the bandsaw, I decided, because I have it, I wanted to go ahead and use the shaper to machine these all down to final dimension. The first thing I want to do is get the shaper set up so it's running at the proper stroke length and that the stroke is in the right spot. By loosening the handle on the top and adjusting this dial, it allows me to adjust the stroke position. Where is the stroke going to be the furthest back and then the furthest forward here? I'm moving it forward so it starts closer to where I have the stock clamped. To adjust the stroke length, I adjust this eccentric on the bull gear. I don't want the stroke length to be too great because that would just increase the amount of time it takes to machine these pieces. I adjust the amount of step over that I get on each stroke by adjusting this knob on the side of the shaper. The further out from the center, the larger the step over will be. If I don't have a lot of material to remove, I'm trying to keep the step over at either the 4 or 6 thousandths of an inch setting. And after setting the cutting depth to around 10 thousandths of an inch, I'll move the table over, start the shaper, and then engage the automatic crossfeed. This side I think is complete. It's got a nice finish on it, so I can remove it from the vise and start on the other side. Checking the depth of this piece as it stands so I know how much I'm going to end up needing to take off the other side. Using the dial on the top of the shaper, I'll lower the cutter by 15 thousandths of an inch and start finishing this side. Well, this piece is to final depth dimension, and it does have a nice finish on it. I love the finish that the shaper gives to these pieces. Now I can swap out the parallels for some shorter ones and then rotate this part 90 degrees and start finishing it for width. This piece is completely unfinished, so I don't know how square it is. So one trick I've seen used on other YouTube videos is to put a piece of aluminum wire between the stock and the movable jaw of the vise. This keeps the side opposite the wire square-ish on the vise and sort of sets it as the initial reference. You can see just how out of square this piece is. It only took off a little bit of this surface material on one side of this face. And I'm dropping the cutter 15 thousandths of an inch, and I'll take another pass. So it only took 2 passes to clean up this face. It's got a decent surface finish. So we'll go ahead and remove it from the vise and turn it to the next face. A couple of these pieces needed quite a bit of stock to be removed, so decided to see how far I could push this shaper here on this run. I believe I'm taking off around 40 thousandths in depth of cut. Shaper did fine. It really didn't have any issues moving that much material. Doing a little experimentation here, just kind of learning how to use this. So I've slowed it way down, and I'm using some oil as a lubricant and taking some fairly deep cuts this time. Rather than strictly relying on the dials on the shaper itself, I put a dial indicator on the tool holder so I could be sure to dial in exactly how much I wanted to take off. Here I'm taking off another 40 thousandths off of this piece. Decided to try to push the shaper a little bit further, see how good my grind is on this tool. This is a 50 thousandths depth of cut, which is about as far as I think I'd want to try with this small machine. And for what it's worth, the 50 thousandths depth of cut was still making a really nice chip. Maybe I could have pushed it a little bit further. Well, now with each of the pieces machined to final dimension, I want to lay out for the holes that I need to drill. I will be using the DRO, although with plastic reader head brackets, but this will at least give me some visual confirmation that I'm in the right spot. I'll start with the Z-axis. I think that is going to be the easiest one for me to replace first, even though it's the least critical, at least in my opinion, of the three axes. I have a Starrett edge finder that was gifted to me by a retired machinist that I met through Facebook. I'll mount that into my drill chuck and then find the center of this piece of material. When I created the drawings from the 3D models for these mounts, I set dimensions from the center of the piece rather than from any particular edge. I think this works out a little bit better because it won't matter if I'm off a little bit on when I machine these on the shaper. I think they're accurate, but if I am off a little bit, it won't matter. What matters is the position of the holes. To start with, I use a short shank 1/4 inch spotting drill with a 120 degree tip on it. The two outer holes are for two 1/4 20 socket head cap screws that will mount this block to the mill. The two innermost holes will be tapped for 1024 socketed cap screws, and these will be where the reader head will mount. After spotting these holes, I will drill through with a number 25 drill bit. Once the hole is drilled, I will give the hole a slight chamfer to help the tap get started. I have a spring-loaded tap follower that I then inserted into the drill chuck to help me keep pressure on the tap. And then I used my Starrett tap wrench with a decent quality high-speed steel tap to finish out this hole. With the first hole tapped and complete, I can move on to the second mounting hole. I do like the idea of spotting and then drilling and then chamfering and tapping without moving the mill. I just think it gives me a little more confidence that I'll keep the holes lined up, especially when I go to use the tap, and less of a chance of being off and end up breaking a tap. With the mounting block for the Z-axis now complete, all the machining's done, I can remove the old plastic one, which served its purpose, and replace it with this freshly machined one. The X-axis mount is almost identical to the one that I made for the Z-axis. The Y-axis is a little bit different. It requires this plate to lower the mount of the reader head so it will clear the saddle. There are 2 existing holes in the saddle that this plate will mount to. I just need to make sure that I measured correctly for when I drill these. There'll be a little bit of play, so if it's off a little bit, it's not that big of a deal. For the mounting location of the horizontal spacer, I want to drill some slots. These slots are going to end up being way more than I need, but it'll at least give me some flexibility that if I need to move this up or down, or maybe change the mount at a later date, I can do so. To mill the slot, I'm going to start by drilling a series of holes so the end mill that I drop in here doesn't have to work so hard. This spacer block will have tapped holes on both ends. One side will mount to the slots in that mounting plate that we finished machining, and the other side will mount to the angle bracket that holds the reader head in position. With the machining for the Y-axis mounts completed, I'm going to go ahead and remove the 3D printed temporary brackets and replace them with the ones that we just finished. Unfortunately, my workshop is not climate controlled. I do not have heat or air conditioning yet, so I do get an occasional bit of surface rust on these machines, so I need to clean that off real quick before I put on the new brackets. I installed the X-axis block off camera, so they're all three now mounted with freshly machined new steel, no longer using any of the 3D parts. This was a fun project. It was relatively simple, but it was nice to be able to use a couple of the different machines in the shop. And I do think that using 3D printed parts as a prototype is definitely something I'll continue to do in the future. Depending on the application, I think it's an invaluable way to see whether or not what you're wanting to machine will actually come out the way that you expect it. Well, that's it for this one. And as always, I do appreciate you watching. And if you're not a subscriber, I encourage you to hit that subscribe button. And if you could give it a thumbs up, it really helps out with the YouTube analytics. We'll see you on the next one. Thanks for watching.